So today we're going to discuss something called alternating series. So in everything that we've been discussing up till now, the assumption it has been that the terms of the sequence are all positive. And the reason that we've been assuming that the terms of the sequence are all positive is so that we're always adding something positive and the partial series is always getting bigger. Because if some of the terms are negative, then the partial series might get smaller, right? Because does it make sense? If you add some negative terms, then your sum will get smaller, right? You'll have some positive terms plus some negative terms, and it will keep fluctuating. So now we're going to cover, well, what do you do if some of your terms are negative? Okay, that's not the correct screen. There we go. Okay, so what if some of your terms are negative? So we call this an alternating series. So let me give you an example of an alternating series, and we're going to define what it is. So let's say you have sigma n equals 1 to infinity of -1/2 to the n. So if you plug in n equals 1, you get negative... Yeah? Oh. If you plug in n equals 1, you get -1/2. If you plug in n equals 2, you get -1/2 times -1/2, which is +4th. Okay, and then if you plug in 3, you're going to get -1/8, and then +1/16, and so on. Okay, so it's called an alternating series because the terms alternate between negative, positive, negative, positive. Right? They jump back and forth. Hence the name alternating series. Okay. So, usually we are going to rewrite this because you can rewrite -1/2 to the n as -1 times 1/2 to the n, which can then be rewritten as -1 to the n 1/2 to the n. Okay, so these alternating series, you can always rewrite it. You can break out this -1 to the n term. This -1 to the n part is what causes the sign to flip back and forth, right? Because -1 to the first is -1. -1 squared is +1. -1 cubed is -1, and so on, right? So you can see that negative is what causes it to flip back and forth. Okay? So we say that all alternating series can be rewritten to look like this. You can rewrite it to be -1 to the n times some b to the n, where the b to the n's are all positive. Okay, so it's usually not given to you in this form, but you can always take any alternating series and rewrite it as a -1 to the n part, which causes the flip back and forth, the alternation, and then this bn, where the bn's are all positive. Okay, so whenever I talk about bn for the rest of this, we're assuming that the bn's are all positive. We've factored out this -1 to the n part that causes the flip. Okay? Okay, so hopefully that's making sense so far, that it flips back and forth. It's really annoying to keep track of the fact that it flips back and forth, so we say, hey, forget about the fact that it flips back and forth. Let's look at what happens if it doesn't flip back and forth. We call that part bn, and then we're going to multiply that by -1 to the n, and that's going to be the part that causes the sign change. Okay, so hopefully you get what I mean by that. Now, you have to be a little careful about this because maybe your alternating series starts off with a negative and then goes negative, positive, negative, positive, negative, positive. Or maybe your alternating series starts off with a positive and then goes positive, negative, positive, negative, positive, negative. That gets a little confusing to deal with, right? If it goes negative, positive, negative, positive, or if it goes positive, negative, positive, negative. So we need to talk about when that happens. So we want to write our alternating series one of two ways. It can be -1 to the n bn, or we can have the same sum, but we're going to have -1 to the n plus 1 bn. So if you have -1 to the n, that first term where you plug in n equals 1, -1 to the first is negative, right? So that's minus b1 and then plus b2 minus b3 plus b4, right? Because if you plug in even powers, -1 to even powers will be positive, right? So if you have -1 to the n, the even powers are positive. Whereas -1 to odd powers will be negative. Okay, now what about if you have -1 to n plus 1? Well, if you plug in n equals 1, you get, when you plug 1 into n plus 1, you're going to get squared, right? So -1 squared will be positive, so you'll start off with a positive b1. Now, when you plug in n equals 2, 2 plus 1 is 3, -1 cubed will be minus, so you get minus b2. Right, so it goes b1 minus b2 plus b3 minus b4, ... Okay, so if you have the index with -1 to the n plus 1, the roles change. The evens end up being negative. Whereas the odds are positive. So every single alternating series is going to be written in one of these two forms. Usually it's helpful to know if you have -1 to the n that it starts off as negative. If it's -1 to the n plus 1, it's going to start off as positive. It just makes it so you don't have to plug in stuff and you just start noticing it. And it makes it easier to deal with. And if you're aware of this, you're like, oh, okay, that's not that bad. Okay. Making sense so far? Right? You know by looking at it whether you'll start off with a negative or a positive term. Cool. Now, let's. So how do you know if an alternating series will converge? Okay, so there's something called the alternating series test. Okay, and what's complicated here is the fact that because you're adding positive and negative, you have a positive number plus a negative number plus a positive number plus a negative number, that partial series keeps fluctuating because as you add the positives and negatives, they start canceling out with each other. And it actually ends up working like slightly differently than as if all your terms had been positive, where it just keeps on getting slightly bigger and slightly bigger. Okay, and they figured this out a long time ago. So what does the alternating series test tell you? Oh, sorry, Burrito's like going crazy. He'll calm down eventually. Sorry, I'm like trying to like get back into there. He's like barking and I'm like, ah! I saw the Amazon man walk away. Burrito, just stop, it's okay. I know that there's a package. Chill, dude. So, how do you know if it will converge? So let's say you have a alternating series of either of the two forms, where it's -1 to the n. Yeah, he's protecting me from the UPS man. You've done your duty, Burrito. So no matter which one you have, it works for either of them. So how do you know if this will converge? There we go. Thank you, Burrito. You've stopped. So it converges if... Oh my god, he won't give up. If time typing. What am I less than or equal to? Oh, there. If 0 is less than or equal to b underscore n plus 1. I'll have to write this and explain to you what it. Okay, I keep on pressing the wrong buttons. Sorry. Let me just write this and I'll explain what it means. Okay. It converges if that's true, and I'll explain what that means in a moment here. And if this is true, here, I'll just write it. So if the limit as n goes to infinity of your sequence is equal to 0, so if you look at those terms, remember the bn is just the positive terms? The minus 1 to the n or the minus 1 to the n plus 1 is what makes it alternate. You forget about all that. Take the limit of the bn part. If that goes to 0, and if bn plus 1 is always less than or equal to bn, what does that mean? It means if you look at some term bn, if the next term bn plus 1 is smaller than bn, in other words, the terms are decreasing. So what makes an alternating series converge? If the terms are decreasing, the terms always get smaller. And remember, the bn has gotten rid of the negative. So you aren't worrying about the fact that it goes negative, positive anymore. You're saying, forget about the fact that it keeps switching back and forth. If the terms are always getting smaller and the limit of the terms is 0, then your alternating series converges. So if those two things are true, boom, you definitely know that what you're dealing with converges. You don't know what it converges to, but you do know that it converges. Oh, thank God, he's finally stopped barking. I see him, though. He's, like, prowling around the front door, like, waiting for the Amazon man to come back. Okay, so let's do an example of this. So let's say you're looking at the sequence, the sum of n equals 1 to infinity of minus 1 to the n plus 1 divided by n squared. Okay, so remember that you forget about the minus 1 to the n plus 1, which makes it start off as positive, right? So this, let's just identify, this makes the first term as positive. I mean, it's not super important to us, but I'm pointing out, right, that you know when you plug in n equals 1, you get 2, minus 1 squared is 2. Okay, so what is your bn? Your bn in this case is everything but the minus 1 to the n plus 1. That's 1 over n squared. Okay, so this is what you need to analyze. Your sequence is 1 over n squared. So you need to check, condition 1 is, are all of the terms positive, and is bn plus 1 always less than bn? Well, looking at 1 over n squared, we know that those are always positive, right? The bn's are always greater than 0, because you're going to take some number n equals 1 to infinity, square it, and do 1 over that. That's definitely going to be positive. So now the question is, well, are the terms decreasing? So bn plus 1 is 1 over n plus 1 squared. And what's bn? 1 over n. Well, we can verify that that's true because, well, if you start with n, that is less than or equal to n plus 1. Right? N is less than or equal to n plus 1. Now, if you square it, n squared is still going to be less than n plus 1 quantity squared, right? And if you take the reciprocal, you know that the direction of the sign changes. 1 over n squared is going to be greater than 1 over n plus 1 quantity squared. And notice that this one is bn is greater than bn plus 1. So yes, this condition is satisfied. the terms are definitely always getting smaller. How did I actually prove that? By doing the work off on the right. Right? I was like, okay, n is less than n plus 1, you square it, that's still going to be true. You take the reciprocal, the direction changes, and they're like, oh shit, well those things are my bn and my bn plus 1. Okay, so condition 1 is satisfied. Boom. Now we have to check condition 2. Well, condition 2 says that the limit as n goes to infinity of the bn's need to be equal to 0. So you go and you check, you're like, well, what's the limit as n goes to infinity of 1 over n squared? And you're like, oh, that's very obviously going to be equal to 0. You could use L'Hopital's rule if you wanted to. So, yes, this condition is satisfied. So now what can you say? So you can say, since both conditions are satisfied, the alternating series test tells us that this series converges. And you check those two things, they're true, thus the series converges.